All right, hello again. So we're starting on 2.3, where we're going to be looking at domain and range. That is the only objective of this section. So we had already talked about what a relation was. So the relation was how a set of points that's our domain is related to a set of points we call our range. So a lot of times that relation can be through an equation. Sometimes we use graphs. There's a variety of ways we can do it. One of the versions we're going to see here is ordered pairs. So you can actually use sets of ordered pairs to designate a relation. So the solution of any equation that is in two variables is going to be an ordered pair. So all those linear equations that we were graphing, we were always looking, we plugged in an X, we found a Y, we had an ordered pair. That was a solution. So a set of ordered pairs is called a relation. So what we mean by a set, that if I had went through and I found, multiple solutions to my equation, I can just keep writing down each of the ordered pairs. When a set of ordered pairs is such that no two different pairs share the same first coordinate, meaning we don't have two x's, we have a function. So what we mean is if we look at this here, this is a relation, and we see that my input x only goes to one output. My input of 4 only gives me one output of 7. My input of 5 gives me only one output of 9. So for it to be a function, said that each one of my inputs really just gave me one output, or each x only gave me one y. So this is also a function itself. So this word didn't show up here, so let me write it here. So the domain is this first set, is the set of all first coordinates, and the range is the set of all second coordinates. That word got cut off at the bottom of my screen. So what I mean by that is my first coordinate, that's going to be all your x values. And my set is going to be 3, 4, and 5. Those are all my x values of the first coordinate of each ordered pair. With your range, it's going to be your y values. Like I said, we don't always stick to this as, all the time. Sometimes we have different variables, but it's a lot easier to think of it as your x values, your y values, first coordinate, second coordinate. Your range will end up being your second coordinate numbers. So in this case, if we're looking at that same relation, it would be 5, 7, and 9. All right, so let's do this again. So this is a function. So a function could just be, like we said, it could be sets of ordered pairs. So this one's sets of ordered pairs of 1, 3, 2, -2, 3, 5, and 4, -2. The domain is once again going to be all those x coordinates. So it'd be that 1, that 2, that 3, that 4. So notice that these are listed in ascending order. And then the range, once again, would be, we'd keep the 3, the -2, the 5, and we got another -2, but we already wrote -2 once, so we're not writing it again. So the -2, 3, and 5, that would be my range. That's all the possible values I can have for y. The domain, all the possible values I can have for x for 1, 2, 3, and 4. So the note that elements of a set are always going to be listed in ascending order, and no element is repeated. So like I said, all my x values were listed in ascending order. I rewrote these because we had 3, -2, and 5 as -2, 3, and 5 in ascending order. And because I already had a -2, I don't write it twice. I just need to write it once. I just need to say everything that y possibly could be. And it doesn't matter if it could be -2 100 times, we only write it once. And this is everything x can possibly be, and we only write it once. So we're going to find the domain and range of this function that's graphed below. So this is, once again, just sets of ordered pairs. So like I said, a function can just be ordered pairs. A graph can just be ordered pairs. It doesn't have to have lines. This one is not consisting of lines. But we have the points -5 and 1 here. So if I was looking for my domain, one of the numbers I know I have in my domain is -5. One of the numbers I know I now have in my range is going to be that 1. This is a point that is at x is 1 and y is 0. So now we know that 1 is in my domain. I'm going to try to put these in order, and 0 is in my range. This point here is when x is 4 and y is 3. So now we see that, kind of skipped one here, that 4 is in my domain. Just checking something here. And 3 is in my range. And then we have this last point here at 3 minus 5. So we have 3 is in the domain, and we have -5 is in the range. All right, and that's how we quickly find ourselves a domain and range. Like I said, we're just looking for anything that x could possibly be. X could possibly be -5, it could be 1, it could be 3, it could be 4. Everything that the range could be is that if I put in anything from the domain, the things that could pop out from my range are -5, 0, 1, and 3. Okay, so for this function, now instead of having ordered pairs, we have a line. So any point that's on this line is an ordered pair, it's a solution. Just as long as it falls in that line, that's going to happen. What we want to do is find each of the following here. So the number in the range that is paired with -2 from the domain, or what we're going to call something called f of -2. Okay, so we're looking for a number in the range that is paired with -2. So that means we're looking for -2, and we're seeing what does it pair with. So when we come up and hit this point on the line, we see that pairs with 3. So this is a point -2, 3. So f of -2 is just 3. Now, if we wanted the domain of my whole function, well, that one's going to be a little interesting to find out. So it's kind of what we did there to find this is going to help us find a range here. Our domain, however, is going to be slightly different. So when we're looking at domain, we're looking for anything that x could possibly be. So we see here that x could be -5. Every point on this line is something x could be. So we're just going down and make sure basically that I'm touching the x-axis. So if I can go from the line and touch the axis at x-axis, everything that I'm hitting on the x-axis is my possible, or is my domain. Sorry, I was trying to get that just right. So what we're getting here is that I have values from -5 to 3. So my domain, there's a couple ways we can say it. I can say that it's x at the smallest, because that's a closed point, x is -5. At the most, because that's a closed point, x is 3. Everything in here, there's a point here that has an x value attached to it. And because we have an x value for each one of these points, basically we're covering everything from -5 to 3. So we just need to write this interval like this. Or we could write this instead. So we could also use just interval notation. Either one's okay. So let me get this off of here. Now we're going backwards this time. So we wanted to find the number in the domain that is paired with 6 in the range. So what we're trying to find is x if f of x is equal to 6. So this is where y equals 6. I hit the line here. Let me go grab me a straight line here. Looks like I'm falling about here. So what that means is that x, the point that's paired here, would have to be roughly about, what do we say, like 2.2 maybe? It's roughly about 2.2. That also means that f of 2.2 should equal 6. Now I'm going to have to put a little bit of the range over here because I'm ran out of room at the bottom. This is D, looking for the range. So the range is all your y values. So when looking for the range, it's kind of the same idea, except now we're trying to go to the y-axis. So all this goes to the y-axis. So sometimes we hit there a couple times, that is fine. It's kind of like if you were taking a light, you're shining a light here and you're shining a light here and you're looking where there's shadows here. That's kind of like the idea here. So what we have here is that any point along here has a y coordinate, and that y coordinate, we're just mapping here to say it's y. So from here to here, it looks like we cover every point in that range there. So when I want to say what my domain is, my range is going to be y values this time, so it's not x values. My smallest possible y value is -1. So at the very least, x is -1. We assume that this is a closed point here, because it looks like it goes right down to -1. At the most, it's going to be 7. If we do interval notation, we're looking at from -1 to 7. There was just one other thing I wanted to add, and it was this set builder notation. So actually, I'm going to get rid of everything up here for a second, just so we have the room. So another way I can talk about that domain and range, if we were using set builder notation instead. So we said domain looks like this, it's x is between -5 and 3, and including both of them. So set builder notation would have been, we write x, a line, -5 is less than x, which is less than less than 3. And then range, same kind of thing, except now we have a y, and we would say that y is greater than or equal to -1, but less than or equal to 7. So yeah, it's basically repeating that interval again, but that is what we call our set builder notation. So if you see notation like that, it's basically just telling you what the range is with an interval. All right, so this is where we get to our first worksheet problem. So if you could take just a little bit of time, and we have this function over here, everything's a closed point. We want to figure out the domain and range and the x and y intercepts. So just to kind of recall what we had been doing before, see if you can find those x and y intercepts. Then tell me like what is f of 2, and then find x for f of x is equal to 3. Okay, so if we do this again for domain, we see here is, like I said, just going down, touching that x-axis. All this touches. So we got a point all along the line here, an x value on the line. So what we're seeing here is that we're starting here at, that's -5, so this is -4. Actually, it tells you the point here as well to make it easy for you. And then we get up to here. It's hard to see if that's 1, 2, 3. So that's where 3 is. So my domain, it's x values. So it's all my x values that are between -4 and 3. Okay, so if we do the other way now, let's get a new color for us. If we do our range is going to be y values, correct? So we're looking for what y is sitting in between. So if we start down here, we see, we're just going to do the side first. All along here, I have y values. So y is a little different because you can have multiple y values. And it's just they're going to coming from 2 different x values. So we see right up here is where I stop. So I like this method because I find like when you have a point here, that tends to confuse everybody. But you're just kind of just covering along what did I cover. But at the least that what we have for our y values, as the smallest is a 0 and the most, it's hard to see that, but it's at 16 up here. We covered everything in here. Okay, I just want you to know it's like this point here is not a stopping point. It's one of the points that gets covered along the way from between 0 and 16. Okay, so x and y intercepts. So we have one labeled on here already. This point here is 3, 0, so it's where it intercepts the x-axis. So my x-intercepts, one of them is 3 and 0. We actually have 2 of them because over here is one more. So that is about -3 here. So this is another one at x is -3, y is 0. So we'd mentioned before that sometimes you can have multiple x-intercepts. I believe I mentioned it. We talked about how we can have no intercepts. But in this case, like I said, we happen to have 2 x-intercepts. If you have a function, however, you should not have more than one y-intercept, which looks to be about here. So that was 14. This is 13. It happens at about where x is 0 and y is maybe 13 and a half. All right, then next, f of 2. So this is telling me this is when x is 2. So when x is 2, I think I'm gonna have to get some arrows here. When x is 2, which is here, we come up and we hit, I think right here. It's a little hard to tell. Let me do that one more time because I got off at the end. If we go this way, then that's my y value. So 10, 11, 12. So f of 2, so when x is 2, that means that y will be 12. So we can say f of 2 equals 12. And then our very last one, we use bright red for this one. We're looking for x when y is 3. So over here, we know that y is 3. We need to figure out what x is. So when y is 3, that is 1, 2 here. So this is okay. I can't duplicate x's. I can duplicate y's. So what we have here is actually at 3, we hit 2 places. So we go out this way and we come down. That's just a little before the 3 there. So just before it. And then here we come down and hit here. So in this case, like I said, it's still a function. This is okay. I can't have f of 2 go to 2 points, because that means I put in an x and got 2 y values. Because what I'm having here is that if x is, according to this point over here, -2, well, y will be 3. That's okay. If I go to this point over here, that's when x is just a little below 3. So let's say it's like maybe 2.9. There we get y is 3. Maybe 2.8. But if you're anywhere close to like a 2.8 in that range, I would say you're good. You were close. All right, so we have a couple more of these for you guys to work on. There's 2, 3, and 4 also. So if you haven't worked on those yet, just pause again and make an attempt at it. And then we will finish it off. All right, so for number 2, I'm going to use this to kind of show it. So we want the domain. So domains all our x values. So we're looking in this direction. So I'm here. I hit everything else in here. And I stop there. So everything from here to here, that will be my domain. So domain is all my x's, such as, and we assume that these are closed points here. If they have a line and it just stops, just assume it's a closed point. It's a lazy way to do graphs, but you see a lot of graphs that way now. But we see the smallest is we get, so if you need to count it, -5, -6, -7, -8, -9. It's my smallest. So we also smallest to largest. My largest possible value for my x's is 10. So remember, you're always writing things in numerical order. Smallest number first, largest number second. Okay, so if we do the domain, or sorry, the range instead, the range is my y values. So my smallest y value is starting here. And I'm moving up. Go out a little bit more here. So I'm moving up, and at this point, I no longer have y values. This is kind of like where my graph stops. So in this case, when we talk about range, remember range is y values. So always make sure it's a y in here. So at the smallest, -1, -2, -3, -4. At the largest, 1, 2, 3, 4. Okay. And like I said, this point here, we're kind of assuming that's like a whole point there that comes down and touches at y equals 4. All right, so intercepts. We have, because it's a function, only one y-intercept. So it's because of like that vertical line test, I can only have one y-intercept there because I can only have a vertical line come down and cross once. So I should only cross once that x-axis. So, or sorry, yeah. That's kind of what I meant. We'll only cross once at that point on the x-axis, so it'd be that y-axis is crossing there. So what we see is that my y-intercept is going to be this point where x is 0 and y is 1. X-intercept, got a couple. So we're going to say x-intercepts. We don't always have multiple. It's just a lot of times that we do. We have one here and we have one here. So this is a point where x is -1, y is 0. And this is a point where x is, let me see, -5, -6, -7, -7, and 0. So f of 4 means that we're looking where x is 4. And when x is 4, we see that y is 4. However, when y is 4, we have a range of values here. So if you had said, like, well, if y is 4, then you just gave me 1 point or something like that, you're partly correct. So here and here, that's where y equals 4. So we have the choice of this point out here. That's one of my solutions. That is when x is equal to -9. We have that point right there. That's where x is equal to 3. But also all these points in here. So sometimes when we have a solution, it could be a point. In this case, this one was just a little weird, just kind of show you that things aren't always nice and fuzzy. In this case, because we have all these x values in here as a solution, solution could be x is equal to -9, or x is any value from 3 to 10. From 3 to 10, all of those are going to pop out of 4, and if x is -9, I pop out of 4. So for D, your solution, one of the ways you might see it as being like set notation, x is equal to -9, or x is between 3 and 10. Okay, this one, the domain is a little different when we talk about it. So we're going to go out each end here and kind of talk about what's happening. So if I start here and I start looking for all my possible x values, I keep going, I keep going, I keep going, I keep going, and I hit here. What we know that arrow is telling me is that I keep going in this direction, and you see there's a slight angle to it. So as I keep going, you see I'm slightly gaining some x values out here. So in this case, if you got kind of stuck here about that arrow, well, what's really happening is I just keep on going and going and going and going forever, for infinity. So that is in a positive direction. I'm going into a positive infinity. So here, that's one direction here. So when we talk about domain, you have x is going to infinity this way. If we go in the other direction, we got a similar thing going on. X values, more negative x values, more negative x values. We hit this arrow. It's on, like I said, a slight curve there, meaning we're going to keep gaining values going in this direction because it's going to keep on going like this. This direction is to negative infinity. So my domain is between negative infinity and infinity. And there shouldn't be an equality there. So you can never equal infinity. So it could be this. So normally how you'd see this domain is we would say the domain is x such that x is all real numbers. So we're going from negative infinity to infinity. We're covering everything. So we are covering all real numbers. If we were to do this with interval notation, it would look like this. So we can't include infinity because to include it means that we'd have to be able to obtain it, and we can't obtain infinity. It just keeps getting away from us. So what we're saying is we're approaching it, but we can't touch it. So as I was saying, we stay open at affinity. Get these extra lines out of the way here. Okay, so something similar happens for, I'm gonna scroll this down a little bit. So we have a similar situation that happens for y as well, or our domain. Sorry, our range. I was trying to write and talk. Like I said, so domain X such that X is a real number. Or you could have said that it's in the interval from negative infinity to infinity, but like I said, we need to keep it open. So when we talk about range instead, so range is slightly different here. So what we see is that right down here, that is my lowest possible Y value. And I keep on going up and I hit those arrows, meaning I also just keep going. So if I'm going up, that's also going to infinity. If it was reversed and I was going down, it'd be going to minus infinity. So my range here would be X such that X has to be just greater than, what is this, negative 16 down here? Greater than negative 16. If we were to use the interval notation, at the lowest, we're at negative 16. At the most, oh, sorry, not X, Y. At the most, our Y is, at the least, Y is negative 16. At most, it's just approaching infinity. Okay, so x-intercepts, we have several. I think I need a little more room there. We have one here that might be hard to see, but that is negative 3, 0. We have one here at negative 1, 0. We have one here at 1, 0. And we will have one here at 3, 0. And then because it's a function, we only have the one y-intercept, which is here at 0, 9. Okay. So we kind of answered part of this in one of these questions here. So if I ask you for f of 0, well, we got it right there. When f is 0, we see that the output should be 9. This one here, when it says, so basically when we ask f of 0, we're asking for a y-intercept. If I ask you f of x when y is 0, we have all those too. These are all the places that y was 0. We were asking for x-intercepts. So that happens at negative 3, negative 1, 1, and 3. Those are all my possible values for x that are going to result in a y output of 0. All right, so this one, there we go. So when we talk about domain, we see here that this is the most that x can possibly be. And we have this arrow going this way, so x is just going for infinity in this direction. So domain is x such that x just has to be, so this is anything, we're going in a negative direction, right? So this has to be values of x that are less than or equal to 2. Or you could have said, at the very least, it's, there we go. At the very least, it's minus infinity. At the very most, it's going to be 2, and that includes it. Okay. If we're talking about range, at the very most for my range, I'm going to be here at 8. At the very least, I'm going to negative infinity. So when we talk about that, that's going to be y. In this case, y has to be values that are less than 8. Remember, that's a close point, so we can also include 8. Or it's values between negative infinity and the inclusive point at 8. My x-intercepts. So we have 3 of them. We have one at -2, 0. We have one at 0, 0. And we have one at, looks like that would be 1. So that's 2 there, and that's halfway in between. So that'd be 1, 0. Y-intercepts. Well, we only have one, and it's at 0, 0 again. So this is a case where we share an x and y intercept. It's the same point at 0, 0. F of 2, once again, we were already told that. We have an ordered pair there. So f of 2 is 8. F of 0 is the origin. So here x would have to be 0.